Hi, my name is Vilson Lu, and I'm here to present our paper entitled Use of SOM for Non-Static Data. S- Self-organizing map, or SOM, is a type of unsupervised learning approach that arranges the neurons in a grid. It tries to mimic how our brain learns. For years, there have been many researches that explore the uses of SOM, from dimensionality reduction to exploratory data analysis. Aside from these, SOM is also being explored as a tool for time series analysis. SOMs have been used to visualize time series by plotting them into the map to see how state changes over time. Works have been done on analyzing students' brainwave patterns. Using SOM allowed them to see how the student emotions changes from one state to the other. Another research studied the patterns of symphony, allowing them to see if there are similar patterns across musical periods from Baroque to the 20th century. However, analysis of multiple trajectories might be difficult, especially those with long sequences. Various similarity measures may be used to compare the similarity of behavior between trajectories. In most cases, alignment of trajectory must be performed before applying any similarity measure. This paper presents the use of edit distance similarity measure wherein the alignment of the trajectories is not necessary. The use of edit distance on EEG and music datasets had shown better results in measuring the similarity between trajectories compared to a pairwise similarity approach in which requires the alignment of trajectories. In our paper, we wanted to compare the results from the proposed similarity measure to the pairwise similarity measure. In order to do this, first we trained our SOM in two datasets. The Reader's Affect dataset from Callow and Ong 2017. The dataset contained EEG data collected from 32 participants, 23 females and 9 males. For this experiment, we only used the male participants' data. The second dataset is from A. Azcarraga and Flores 2016. The symphony dataset consists of 1-second segments from 45 symphonies collected from 15 composers across 5 major musical periods. After training the SOM, we clustered the nodes using k-means clustering. The next step is plotting the time series, the brainwave and symphonies, to their respective SOM. Once the time series is plotted into the SOM, we now refer it as a trajectory. This trajectory will then be stored to be used for evaluation. After plotting the trajectories into the SOM, we evaluate the similarity measure by giving them an unknown trajectory and letting them find similar looking trajectories. We then check the results using visual inspection. Here is the result for the Reader's Affect dataset. Figure 1 here is our unknown trajectory. The line starts from a yellow color, then gradually changes to a red to show the time variable in the trajectory. Figure 2 shows the top 10 similar trajectory based on our proposed approach, while Figure 3 is based on the pairwise approach. For the proposed approach, the resulting trajectories were similar to the unknown trajectories and to each other visually. It also could be seen that the trajectories that came from the same user were considered as the most similar to the unknown trajectory. We can see that the top 10 results all came from user 14. On the other hand, the pairwise approach barely showed resemblance to the unknown trajectory. The trajectories mostly stayed on cluster D on the lower right side of the map. The resulting trajectory is simple in the sense that most of the trajectory generally stayed in one cluster. This is because the pairwise similarity measure tends to choose long trajectory with simple sequence. Those long but simple trajectories have a higher chance of matching to the unknown trajectories. Next is the symphony dataset. The unknown trajectory here is the Mozart Symphony 41 Jupiter. It was described that the trajectory has a major diagonal movement. For the proposed approach, it showed that Stravinsky's Symphony in 3 movement was considered as the most similar to the unknown trajectory, while Shostakovich's Symphony 8 Stalingrad was considered as the most similar trajectory for the pairwise approach. In conclusion, it showed that using an edit distance approach resulted in a more similar trajectory visually than using the pairwise approach, However, there were still some limitations to this research. First, the research used qualitative analysis for the similarity measure. It would be best if there was a way to score the similarity measure. Second, the approach only used the cluster, where the proposed similarity measure did not consider the actual location on the map.